So now we are all allowed, we can't ever skip a class now.
Oh wow, that's awful for you.
Well, it's for the people going to conferences.
Yeah.
It's it's an issue. I thought you were being sarcastic.
No.
Wait, so they said you guys always had to be at your teaching slots?
So something has to happen that day. You can't just say, okay, class off, I'm off to a conference. And to be very honest, I tend not to go to conferences unless I really, really have to. I let the grad student go, because I do feel very guilty about not teaching. And so, but you can't always do that. And I'm at a stage in life where I don't have to become famous. But when you're a young person who wants to become famous, you have to go to conferences. So we've been told that if you do, and because of the reason, because I think there were classes held that had there were courses on the book that had no lectures. So when you catch one such thing, you have to make sure now that every class has lectures, and if nothing else, you just play a recording of the lecture, but you have to have a lecture. So. Anyway, questions?
What exactly are we measuring for the NIO client? Because
okay, is it ambiguous?
It's kind of ambiguous because measuring when you set the input string doesn't give you anything.
No. Hang on. If I go and set input string 10,000 times or whatever, 500
right.
times. Your set input string is going to send and it's
wanting us to measure the sending.
Yeah, just at that point,
sending?
Yeah. That's easy. I don't mean for you to go and figure out, how long it takes for the message to get to the other end, because that's kind of hard to do.
That was my question, because I can measure the other end and wait until 500 commands come in simultaneously and then measure the time of the process.
Yeah. No, I just want to see how your computation is being influenced. And maybe you're not seeing any differences.
Yeah, that's.
Well, you're certainly seeing difference in semantics, aren't you? Do the commands go? They don't get executed quite, right? Because there's no markers. So the whole point, the thing though, is that there are system layers involved. I've always told you that in IPC, the cost is not of sending the data across the network. It's the layers within the computer. So we're trying to measure the cost of those layers. Okay. And when you do RMI, you will see the effect. Okay. And you'll say, it was good that I'm a real man and I programmed in NIO. Okay. A real programmer. Zach, did you?
So the answer to that question was start timing at the beginning of your send, stop timing at the end of your send.
Just try to loop beginning and end. It's pretty simple. The only issue is to be able to do the set input string, from the program rather than from the user, and also allow. I said something else about local execution also versus just allow. Don't intercept have a little boolean that decides whether the communication layers will even intercept the event or not, and see what happens when there's a server around. I forgot what conditions I gave, but all of those conditions will be important when RMI is implemented. So I want you to compare. That's why I didn't ask you to do this in the first assignment, because I want you to now compare this with RMI and see what the difference is. Why people want asynchronous systems. And underneath everything is asynchronous, So it's
For those who have started, how is the time expensive, or been battling some problem sets elsewhere?
I haven't actually implemented RMI. I was just trying to get what I was supposed to measure before I got.
Yeah, that's probably a good idea, but you're still in that mindset. Okay. Once you understand RMI, it should all be simple to use.
Simple.
That was my other question. There's two methods to do this with RMI. You could feasibly do something like a mailbox on the server, and the client could keep polling that mailbox.
Oh, yeah.
Or you can do not an asynchronous, but a callback from the server. Would you prefer the callback?
Or you could just send the messages directly to the clients also. So there's all these options, right? And polling, you guys, this web generation just loves polling, right? But with Ajax, you don't have to poll. So, what did your OS teachers teach you about polling?
Something
Something that came out today, like REST hooks built on webhooks or something, prevent polling.
Yeah, so I mean the web, the web was created for something and it's being used for something else. So it's interesting. I've never got excited about the web. I'm excited about what it does, but from a technology point of view, I've never got excited because it's like you just are not using the right paradigm to do the things. It's just that it's pervasive.
So you think it's just a big hack?
No, I'm not going to say that. I'm not going to say that. But it's a long time ago, before the web, people were doing remote procedure calls over email. Don't laugh. Don't laugh. They were using email as a transport mechanism. You were guaranteed to get, to send the message across. What if you were just updating your status report? You just made a remote procedure call. It got serialized into a text message, which got sent by email, which got received by email to another process, which read the thing and gave it to your waiting process. Okay? So compared to that, with the web, you've come a long way, But compared to what you could do, but that was, and there was no firewall issue. So this whole firewall, having spent some time in Microsoft, it's just everybody's cheating, So web is meant for something. So you say, okay, we'll use web to do remote procedure calls. It's not meant for that. But so it was really meant for browsing pages. But if you're going to do remote procedure call over web pages, you can do any service. So the web port is always kept open by all these companies, so that you can only do do web kind of things. But now on the web port, you will do anything. So what's so special? I mean, it's just from a conceptual point of view, I don't understand this. It's just this cops and robbers, It's just so it's we and some guys will try to detect what you're doing and say, oh, you're not doing regular web things, you're doing arbitrary services, and some won't. And it's I just don't know how to think about it. Okay, anything that works and is so used, is more than a hack. And they've got XSL. I mean, they've got this model view separation also. But I just have never got excited about the web from a teaching point of view, from a research point of view. So we were still trying to understand what remote method invocation really means, and we saw that the whole idea is that from one computer you've got some object, a client object, that's invoking methods in another object. Okay, and we'll do it in a very modular fashion. That we won't change the compiler, so it's not that every method compilation is different. Okay, we'll just let the regular compiler work. And we will go in, when the client object really wants to go in and invoke a method in the server object, it does so indirectly through and invokes methods in a proxy object. To the compiler, that is the target of the method. To the user, from the user point of view, it's going to some other machine. And the server proxy has no semantics, it's just a forwarder. Okay? It's got the same interface as this guy. So in that sense, it is application server object specific. But it doesn't do the add, it doesn't do the subtract. It just forwards the call to some other object. Okay? So that's what's happening. That's a nice, elegant solution, and which allows you to build something on top of the regular compiler. Okay. And we saw that from the client object's point of view, the method call is much like a local method call, except you might some things that are outside your control may happen that won't happen in a local method call. And so for that we have a checked remote exception. Okay? We saw that. And so the method declaration of the interface that the client object uses must have in each method, in each header, must say throws remote exception. Okay? And the class of the server object must implement remote. Okay? So that it's callable from somewhere else. So something has to change both at the client end and at the server end. There's a forwarder here, the server proxy, that's forwarding a call to some agent here that goes and dispatches the call to the right object. So you need some stuff to happen here, need some stuff to happen here. So there's some awareness in both the client and the server. Okay? And so two questions we have are, so we are in the client, in this computer, the client object is invoking a method on some other kind of object, this proxy object. When is its class created? And then the next question is, when is the proxy object itself created? Okay? So two questions. And are these two times different? Somehow are they combined together? So when do you think the proxy class would be created? And when we talk of when, there's this notion of binding time. You guys have heard binding time? So in which courses at UNC did you hear about binding time?
Programming languages, 524.
Okay.
Just last semester, and I think once in believe it or not, in like 401.
Yeah, it's good.
With Headland.
Yeah, good. So many things you guys learn from Headland. And the Liskov thing. So binding time has to do with, so what are the various binding times that people talk about? Early and late binding, okay? And early binding is evil or late binding is evil? Or depends.
Depends on what you want.
Late binding is generally evil. That's it's people tend to bind much earlier than they should. People use less indirection than they should, and the cost of indirection and late binding is generally time. But often you can get late binding without performance. Okay. So there is early and late binding, and then what other kind of binding times do we talk about in compilers and programming languages? So what are some interesting times that
Compile time? Yeah.
program writing time? Various kinds of compilation time, link time, load time, run time, right? Start time. When in the case of when the shell starts a process, when the process is started, some bindings occur, and then some bindings can occur while the program is executed. Okay? So when do you think the proxy class is created? Runtime, compile time. Classes are created at compile time, no? What's this? You guys think?
What would be the reason to delay it?
That's a good question. Except for the rule that late binding is evil. If you just believe in that blindly, yours is not a reason why. Yours is to just always bind late.
I mean, your connection to the server would be like parameterized some way. Like you give it a host name and a port.
Yeah, so that's fine.
And
That's
then
fine.
You got that.
Why would you generate the classes at runtime?
Well, what if you don't have the remote object?
Okay, there is two issues. Class created, when is the proxy created?
Sorry, yeah.
Let's go and talk about the class. When is the class created? And why? And you could imagine. So can you imagine classes being created at runtime also?
If you're getting past code remotely.
So Java, do you think Java you can do that? You can go and create a class. You can create a text, use a text string, compile it, and create an instance of it all in a program. It's wonderful. This kind of stuff you could only do in AI languages when I was growing up, and people said, "Oh, that's dangerous," but people can do it now. Okay. So would there be a reason to create this class at runtime, even though Java will let you do it? So let me just show you how this. No, the processes have to be by definition. Processes means execution time.
No,
Proxies, the instances, they happen at runtime, right? They happen in an address space of a certain process which is executing at runtime. I'm just talking to class. And let me just show you how this compile time might work. And actually this you can do this. I can go and say RMI-C, which is my RMI compiler. Whole idea is that you do Java-C. After you've done Java-C, you do RMI-C, which is a layer above it, which will go and create the class. And in that class will be the code to forward stuff. And also there'll be a skeleton class, which I didn't show here, which is at the server end, which will go and intercept stuff that is being sent by the stub class. Okay? So if I do that, I say distributed RMI, and this works, this works from the class code. It just analyzes the class code to create another class. And so this is my counter class, and this is my stub class. Okay? This is the class in which my counter's proxy class exists. This is the class that has the methods that get invoked when this client goes and calls the method, does remote executions. Okay, and I don't know why I don't have it here, but there's also a skeleton class created. Okay, which is the class linked to the server, which will go and intercept traffic from the, maybe today it doesn't happen. At one time it used to happen. Maybe now they have something that's built in to intercept that. I think that's what happens. That's what's happened, in fact, now I remember. That they used to have a separate class created for each client class to intercept messages from that, to dispatch the methods, right? The method call came and it said, I want to do add. It says, oh, you want to do add. So the add comes as some kind of string or number and says, then you go and call the add method in this class. Or you want to do subtract. Then you call the subtract method here. Okay, so for each class, a separate dispatcher was created. I think now a single dispatcher dispatches messages coming from all kinds of subclasses. So the skeleton class is not created, perhaps, because I think I did. You know, when is the date here? 2011. Yeah, that's pretty recent. And I think at one time the skeleton class was also created. Okay, but at least you see what's going on. That you do need some kind of stub class here to intercept your method calls. Okay. And those of you who've used RMI, okay, let me just see what comes next. So pre-compiler works from object code and produces object stub code. And I think, so just to give you a problem, you know, what wrong things can happen. So you tell Eclipse, okay, compile my stuff, and it doesn't work because you forgot to do the RMIC. You forgot to go to the command interpreter and say RMIC because Eclipse doesn't have that built into it. Programming environment doesn't know which are your, you know, it could, but it's not smart enough at least to go and figure out your classes and implement remote. And even if it's smart enough, it doesn't know whether you really want the stubs or not. Just because you have a class that is remotely invocable doesn't mean that you will create a stub class. You could do it by default, but you notice that this stub class is pretty big. I think that's what my next thing is. That's 933, that's 1977. So maybe you don't want to waste space. Okay. Anything else you think will happen? Bad things will happen with Eclipse. Let's say you went out and you created the stub class, and you told Eclipse, build again, or Eclipse just built everything again. What's it going to do? Sorry? It'll get out of sync. Worse, or even if it doesn't get, even if things, yeah, that's good, it'll get out of sync. And a symptom of that is it'll just delete your stub class, even if it didn't get out of sync. So that's a very good point. That this getting out of sync is a dangerous thing, which means you want late binding, right? Or you want to sort of build this part of the compiler. Okay, so those of you who've used RMI, have you done this? You haven't used this, done this. Yet you've been able to use proxies. So what is the equivalent of creating a stub class, that some action you've done that is equivalent to creating a stub class in RMI, for those of you who've used it? Or if you haven't, just invent some kind of API call to do this. So I need a stub class, right? I need a proxy class. I don't want to do RMIC. I don't want to change JavaScript, right? So I'm going to do late binding, which means that this class will be created dynamically. Or I want interpretation. I shouldn't say dynamically because I want some kind of interpretive solution rather than a compiled solution. Okay? But I still need to go and tell somebody that I want this. You know, where I did RMIC, I have to do some action at runtime. So what could that action be? What would you call it? And how would that action, what kind of parameters would that take so that you could do this at runtime?
I mean, I guess you could do some kind of dependency injection thing where you could have like an interface to the stub, take that into the constructor, and then at runtime, you could, anything that fulfilled that interface, you know, whatever proxy, you happen to have in the class path that fulfilled the interface, you can pass it in.
Okay, so
Dynamically build it.
okay, so just let's get down to details. So I want to call a constructor of some kind. I want to say new, some class name, and then the argument is an interface?
Yeah, so like class A, the constructor takes in, you know.
So let's say my counter. Counter is the class
Okay, yeah.
that I want to generate a stub class for. So now in your world,
So,
just tell me what the programmer should do at runtime.
Okay, so counter has a constructor that takes like an I counter stub.
So hang on. So the programmer will have to create a special kind of class now.
Well, the programmer has, yeah, it would be an interface.
So the interface is a counter interface already, or distributed RMI counter interface, right?
Yeah.
So you're saying the programmer will create the stub class themselves?
Yeah. I think I've lost track.
Here the compiler is creating the class, right?
Right.
That means there is some mechanical way of going from an interface to the stub class. There is some computer method to do it. I just want to, so I don't want the programmer to do more work at runtime. So I want the programmer to just have this happen automatically, but just go and tell. So right now we tell the system to do this action at compile time, right?
Okay, so you're saying something that you can do so that it happens at runtime instead of having to run RMI-C.
And I could just go and have a call that says RMI-C class name, right? I could do something like that, obviously. But can you think of it? Sorry? So that's how you'll implement it using reflection. But what's my API call then? RMI-C interface name? Sounds reasonable? Okay, awesome. And those of you who use RMI, you didn't quite do something like this. So what did you guys do? Try to go and think about doing the proxy object and the proxy class at the same time. The first time the proxy object is created of a certain class, we'll create the class. So first time we need the proxy, so we'll just do the proxy object at runtime. And if the proxy object doesn't have an appropriate class, we'll generate the class at that. Next time we do the proxy, when we try to get the proxy object, we already have a class of that kind. Okay? So that's a more convenient interface because you can go and create the proxy object. You just have a call to say, create a proxy object. And when you say create proxy object, you say create proxy object for this server object. Okay? Server objects type we already know. So I don't even have to say RMI-C distributed RMI counter. I just create an instance of a counter. Okay, local instance. I go and say now system, I want a proxy for this object. Okay, and it goes and says, and I want such a proxy to be distributed to the whole world. Okay, I'm at the server end, and I say, I want proxies of this object to be available from the rest of the world. That's what I really want to say. Right? Because I can have a counter in one process, counter in another process. They all use the same counter class. So each of these processes says, look, I want a proxy for this particular object. This is my server object. So hey system, if you don't already have a proxy class for it, create a proxy class. And if you have a proxy class, give me a proxy for this object. I'm at the server, I'm not at the client. I'm at the server, I have a regular object, a counter. I tell the system, please create a proxy object for this. And it'll create the class and then the object. And what am I going to do next with that object? Send it to? So the client doesn't know, client is going to contact me. Client's going to client, I don't know who my clients might be. So where am I going to put this object? A name server. Some server that binds, that has a name and object proxy value pair kept. And that is RMI registry.
So the bytecode's actually just sitting out there on the server, and the clients go to download this Java bytecode?
No. Okay. So what's going to happen is that the proxy object is created at the other end. this end. And you can imagine when you do a lookup from that place, at that time the class of that object is, in this case, the class is sitting at the client. Okay? You can imagine in the other world where the class gets automatically created at runtime. At that end also. Both ends. Actually, a class doesn't get created. There is an interpreter that just interprets things in a certain way. We'll see that later. But think conceptually as a class being created. Just as there's a universal skeleton here for all classes, there's a universal proxy for all objects also. Okay, which goes and says, okay, which class am I supposed to be a proxy for, and it behaves.
So when it gets a message, it takes the message, sends it to the appropriate proxy, and then the proxy sends the stuff to the actual class that the programmer can see.
No. So forget what I just said. Imagine that the class just got created.
Okay.
We'll see later how it's done in a different way.
Okay.
Conceptually, a class gets created.
Okay.
That has the same interface as the other one. You can fake that in other ways, which when we study that, we'll just understand the problem.
I feel like I've kind of been missing the boat for about 5 minutes now. I'm wondering if we could talk about like the essence or like the essential flow.
Yeah. We'll talk about all that. Yeah.
Okay.
It's coming.
Okay. Honestly, I was.
Okay, so let's understand firstly. I need at the local end a proxy class. I need a proxy object. If I need to have a proxy object, I need a proxy class. Okay? Imagine that class being an instance of this class, which is what happens when I do RMIC. This class could be created at compile time, or this class could be created at runtime. And when it's created at runtime, it's going to be created both at the client end and the server end. Because the client end is the one that has to sort of register a proxy with the server. Okay? So it has to go and have that class at its end. And the client code also needs that class because it has to interpret it, use a proxy. Imagine this all happening at runtime, and the process gets triggered by the server saying, here's a local object. Hey system, convert that into a remote object. So the system says, oh, local object, I know what your interface is. I will go and generate a remote class for you. I'll create an instance of that class, which is a proxy object, and I'll register that with the RMI registry. Okay? And then when that object comes across to the other end, it goes and says, either you can send the class along, you can do that actually in Java, or you can just generate the proxy all over again from enough information. Okay? In which case, both proxies are happening to be instances of this particular class, which is generated at runtime from the interface. Right? Given an interface, I know exactly what proxy class to generate. Okay? That's conceptually. Now, what really happens is that all proxies happen to be an instance of the class proxy, which is a very powerful class which can fake you into believing it's a proxy of this class or that class, and we'll see that later. Okay? So if you actually go to RMI and go and see what the class of that proxy object is, it'll say proxy. Okay? It won't say RMI. Even though this method did exist at one time, it can exist. It so happens that they've got yet another way of doing things. And I'll just say that's the interpretive way of doing things rather than the compiled. Okay?
Thank you.
And it'll get clearer.
Okay.
And when you guys implement it, it'll be so clear that you say, why did I have to be so clear? And that class that I was talking about, that method I was talking about, which takes a local object, converts that into a proxy object, and in that process possibly creating a proxy class. If an instance of that class has never been exported before, then you will at that time create a proxy class also. Okay? Is this particular method. Okay? And how many of you guys have used export object? Okay, one person has. You don't have to use export object. You can implicitly do export object another way. Okay? But this is really a call that occurs at runtime. Okay? And it takes a port number, which must mean what?
It's basically because the object resides on the server side, it will listen for calls from the stub at that point.
Underneath there's something. an IO socket, it's sockets. So basically, export object will create a little connection, underlying connection. That is registered at this port. Okay? And so this port is going to be used by the client to go and send messages to it, which get processed and converted into remote method calls. Okay, so this universal RMI skeleton that I was talking about, that is the skeleton that goes and listens to messages on this port and then forwards. Okay, so that's your port. And if you don't give a port number, I think it just uses a default port. Okay, or if you give a port number of 0, it uses a default port. I forget what the exact. We'll see that later. Okay. So there is a particular class which has a static method, which is export object, which says take my local object. You have to first create a local object. Okay? And that makes sense, right? Because ultimately, that local object's methods are invoked when a remote call comes in. Right? So the counter has to reside at this point. And then you go and create a proxy for it, and you do this, and you first create this your class, and you create the proxy at that server end. Okay? So this call. Okay, and before we go further, let's just go and understand things better. So supposing my counter is this, okay, that's enough information to create the proxy class. Okay, and supposing I go and say I remove the line throws remote exception. In interpretation, what do you think is going to happen when I export object? What's going to happen? Sorry. It'll either you could do that, but basically, since this is a remote interface, the client can call all methods in this interface. So it'll just say you can't have local only semantics. Okay, and it'll just go and give you exceptions. Okay, saying sorry, illegal argument exception. It's not a very nice. I wish they had a better name for it, because I've sometimes got confused by this. What do you mean illegal argument? Okay. But it really, that doesn't sound like a good name, right? Illegal argument. Oh. I guess the argument to export is illegal. Okay? But it says illegal remote exception. It doesn't go and tell you which method is the fault. Okay? So be ready for such errors. Okay, in RMI. Okay. In RMI, if you just copy code from somewhere else and don't understand things and you just miss out on one thing, it'll take you forever to debug. Okay, because you don't understand why you did what, and so it's and also even if you understand, if you miss out a piece of code, just because it's so powerful, that a single line you miss out can cause big change. So that's the danger in RMI. It gives you this abstraction, but it's doing so much in each line that if you miss out a line, you miss out a lot. Okay, and otherwise, RMIC is going to complain, okay, and give you compile time error. So here's a good example. The same error can be given at compile time or as an exception. Okay, so typically you say, oh, these kind of errors are exceptions and these kind of errors are compile time errors. The same thing could either be a compile time error or an exception, and you really see late binding in effect here. You see binding time. Okay, so we understand that there is a proxy class, and the proxy class is created, at one of these two times, and implicitly, logically at least, and export object is the one that triggers this whole process at runtime. Okay. Okay. Conceptually, there are a lot of other issues before we get to the whole flow. So let's talk of parameter passing semantics. So we've got this proxy object, we've got this server object. We're going to pass parameters to that. And, what are the semantics of parameter passing? And you would say, oh, parameters, there's, is that an issue? But if you've looked at, so in C and Java, there is only one kind of parameter passing. And you guys have studied parameter passing by
value, by reference, by name.
Okay. So where did you study this stuff? In what context?
Programming languages. Again, 524.
Sorry?
524.
Isn't that a good class? You always
Depends on who's teaching it.
Yeah.
It also depends on your definition of good.
You mean whether you have low bar or high bar?
Yeah, exactly. Well, no, and I think also that it's just a survey, so you either get a few topics pretty deep, or you get
It's
a
a
lot of
tough.
topics with no depth at all.
You know, and that's a trade-off every instructor has to make. You know, I don't know what to do in this class. Do I do, go more in depth, more in, it's the first class. I can go either way, and there are pros and cons there. But good. I mean, you understand. But if you had studied Pascal like I did, with every parameter you went and said, is it by reference or by value? Okay. And
You can see that in Java also. The
Primitives are by value, and
by
objects
value,
by
and
reference.
everything else is by reference.
Yeah, that's right. Unless that's my only reason.
And it's all.
it's all by value.
Oh, well, okay. Yeah. I mean, because the value.
Value of
reference
reference is a pointer.
Yeah.
Right.
Okay.
In C, it's all by value. You can pass an address or you can pass a value, but it's all copied.
Yeah.
It just so happens that the object, whereas in Pascal, you could take an int value and either pass the value itself or pass the address to that. Right? So you could take, you never declared pointers directly. You could declare pointers also, but then pointers were just copied. But you could either go and say var parameter, in which case when you go and pass that parameter to some other method, it can change that value. Okay, so you can go and pass a counter to a method, and the method can increment the counter. Okay, and that was a very convenient thing to do. But you can't do that in C and Java. The fact that some objects you only get pointers to, okay, is an orthogonal issue. And it so happens that objects, you always, the variable always holds. The variable you're passing always holds an address. Okay? So the R value, so whenever you go do parameter passing, there's an R value and there's an L value. L value is the formal parameter. Okay? And R value is the expression you're sending to the formal parameter. When that expression happens to be a pointer, sure, that pointer is copied. Okay, whereas in Pascal, when that R value happens to be a variable, then you pass the address. Okay, so it's confusing because the effect has the same effect, but it's just that you have values in the variables. Okay. So there is this call by reference, call by value, and the whole idea of call by reference is that the callee can go and change things at the caller end. Okay, and so caller and caller can share memory if language has call by reference or pointers. Now, in a remote method invocation, can those two ends share memory? So what should we do? I can either be sending a primitive value or I can be sending an object, right? And you'll have to. So I have to copy. Okay, so if I send the value 5, I send a copy of 5, right? That makes sense. What if I send a counter? I serialize the counter I send it. We studied serializable in the lecture 2, so that was good. What if I send a remote counter? I could send an instance of remote. I could send an instance of something that's a serializable but not a remote. I could send something that's an instance of just serializable. I have all these options. So everybody quietened down when I said remote. So when that object is a remote, what else could I do besides sending a serialized copy? Sorry?
Do the function calls if you have the object to begin with, and then for that.
So what I'm sending, okay. So I am one particular, I'm the client. I'm making a call in the server. That call is remote, we know. That call itself has as an argument a remote.
Right.
Okay. Fair enough. I should be able to do it. So I'm passing to the other guy not a serialized copy of the value, but I'm going to pass to him a proxy. And he's going to take that proxy object and call methods back. So it's almost the call by reference. Well, it's almost like reference, right?
Right.
The whole idea of reference semantics is that the other end can change my data back. If I have a copy, then we have two divergent things. Now we have one conceptual object. So I made a remote call which takes as an argument a remote. I made a call on an object that implements remote, who's a remote, which has a method that has an argument of type remote. Fun stuff you can do. Hey, you need to do this kind of stuff in your next project. You need callbacks.
I just don't follow, like, if you pass up, like, a list, a list in Java, and then inside a method you do list.add
Yes.
one,
Okay.
and then you return.
Fine.
The
One.
the list will have one item in it.
Yes. List has.
It went from having 0 items to 1 item.
Yeah, you did list.adds the number 1.
Yeah.
So this is list of integers.
Mhm.
Okay, so that's an easy thing. You just go and send integers, are primitive values. They don't implement the remote interface. So fine, you've
I'm
added.
saying that not remote at all, just the whole call thing is confusing me. Like that.
You said everything's by value, right? That's what things bothering you. Or
Well,
copy by value.
well, yeah. I mean, I guess where the difference between copying
The value of a pointer.
The value of a pointer.
And
Yeah, it
referencing.
has the same thing. It's like
Yeah.
you're past that value is the reference, to the thing.
No. In Java, in int5, okay, is a word in memory, right? And it has an address.
Right.
That address is never ever copied. When it's an int value, when you go and say list.add5, now list.add5 is a very funny thing because you don't add non-objects to lists.
Right.
So what you end up doing is converting that 5 into an instance of the class, and then you go and pass an address of that value.
Okay.
But back to your broader point.
Yeah. I mean, it could be anything. You could add a list of person and then create a new person and put it in. But the thing is, if you have an argument into a void method, create an object within that method, then add it to a collection. That collection, at the end of that, or at the beginning of the method that has 0 objects, will at the end of the method after the call have 1 object.
Because pointers of lists are sent, right? Pointers are sent, so the address is sent across.
A copy of the value of the pointer.
Yes.
Right.
Which is why we don't distinguish.
So that is why it has got the same, you can achieve the same result as, so basically what Pascal said was a type and the way it is sent are orthogonal.
Okay.
An int value can be sent by value or by reference. A record, which is like an object, can be sent by value or by reference. If you send by value, a copy is sent. If you send by reference, a pointer is sent. Okay? There was no, please give me pointer of this particular memory.
So that's what it is. They separated the type from.
In Java, they say if you're an int, it's by copy. We will store the variables that hold ints will have their values, and if it's an object, the variables that hold that object will have their address. Okay, and you will send the address.
Not just ints, but all primitives, right?
Sorry,
Primitives by value, right?
Yeah.
All primitive.
primitives of value and objects are by reference.
That makes sense.
So in local semantics, you can take objects. You cannot copy objects in local. There's no way you can copy unless you say serialize and then send the serialized object. Okay? So if you really want to change back the old object, okay, that's not a problem in Java because all objects, the pointers are sent. Because you can say they're sent by reference. But the point is they're stored by reference, they're accessed by reference. Everything is, is a pointer there. And now when you go to remote method invocation, I'm saying by value semantics seems to be the only reasonable semantics. Right? Because the address spaces are not common.
Right.
Okay, that's what I'm trying to say.
Okay.
But you could go and send a proxy object to the other end. Okay? And whenever you go and access that other end proxy object, all the method calls come back here. So effectively, you are sharing state. Okay? So the question is, do the caller and callee share state or not? And in Pascal, when you pass something by reference, you can share state. In Java, when you pass an object, you can share state. And in remote method invocation, basically you go and if that object implements remote, then you have a hope that you can share the state. Okay? And that's a very interesting concept, and then we'll go to replicated objects, will confuse things even more because they combine remote and serialized in a way, interesting way. Okay? But we'll get to that next. Okay? So you guys understand? And in your project, you will need to have, if you want a callback, you call a remote method, and you register a callback. So you're going to pass in the remote method some remote object that can go and get the callback. So this is an extremely important concept for you. Okay? Okay. So either a serialized copy or proxy to a parameter is passed. So either we're going to send a serialized copy, or we can send a proxy to the object when we're doing parameter passing. We have these two choices in remote method invocation. And the question is, when should we send a proxy and when should we send the serialized copy? Okay? If the object does not implement remote, if the object has not been exported, then we can't send a proxy. That's clear. Okay? Because a proxy can be only sent if that object has been, if the proxy has been created, which means you have to have, the proxy can be created only if the object is a remote and has been exported. Okay? But when the object is both serialized and a remote, which should we send? Sorry, what is your answer?
I think it depends on the nature of the object.
But parameter passing, we've got no little keyword here. Like we had in Pascal, var, or in Ada it was in, out. Can you guys see the difference between var parameter and in, out parameter? Did you guys study that in your programming language class?
C#, they've done that.
In, out?
Yeah.
Oh, it has ref. I like C# is nice.
Yeah.
So in, out is you copy in and you copy out. It's not that when you change within the method, the changes are reflected. And the optimizer's job gets much easier with in, out parameters, as it turns out. Okay, there's no aliasing. Okay. So we're not going to have that. Maybe it depends, but we can't have that keyword. So if you were to choose between one or the other, what should you do?
Well, in that instance, it'd be safe to do a proxy.
Send a remote, send a proxy. Why do you say it's safe?
Because you implement the remote interface, and so therefore
You can do proxy,
you have the criteria.
but you could also implement serialized. So you could send that also. So I'm just saying it's not an easy, So it's got to do one or the other. And so proxies are generated by callee process through export. This is the point. That, a proxy is generated when the export call is made. Only remote instances can be exported. And this is what Java does. It says, has it been exported? And it can't be exported if it's not remote. If so, send a proxy. Otherwise, is it serializable? Send serialized. Otherwise, complain. Okay?
Now, by export, you don't mean has it already been exported. You just mean was it implemented both?
No, and has been exported also. Or you generated a stub for it. One of these two things has to happen. So we'll say that generating the stub class is really a compile time export. Okay? Which is very convenient semantics from your point of view. And the point is that, a lot of guys might implement serializable. If they also implement remote, then they're doing something nice. Then we don't have to send a copy, we can just send a reference. Reference meaning a proxy object. Okay? And let's just show you how this really works. So there is this object outstream which is being used to write all the parameters on the network. Okay? By default, it's going to go and write a serialized copy. But what the serializer in the object output stream does is it has a method called replace object, which does nothing by default. So think of that as an abstract method, except it's a null method. Okay? And the RMI marshaller. Okay, marshalling means taking a method call and converting that into a message. The RMI marshaller is the stream used, is the implementation of the stream used to go and send these arguments. And what's it going to do? It's a subclass of object output stream, and what's it going to do based on this picture? And which will do what? It'll check if the object is a remote. And if it's a remote and exported object, it will go and marshal. It'll serialize the proxy rather than serializing the object itself. Okay? So you're sending serialized copy because you're sending a copy of some kind. The question is, are you sending a serialized copy of the original object or a proxy of the object? Okay? Question? So think about it. If I've got a counter, I'm copying in one case the value in the counter. So now we have two different counters. In the other case, I'm copying the port number and the host number of the host where the counter is.
Nobody asked that. That makes sense then.
Okay, so the question is, what state is kept in a proxy? Proxy is a forwarder. If it's a forwarder, it has to know what? Where to forward. How do you decide where to forward? Host, port. So when this proxy goes to the other end, it knows exactly how to come back. The method knows how to come back. Okay. So, I spent a lot of time, I told you, to create this framework where you can actually implement remote method calls. And all that effort seems worthwhile right now, because then you will see, when you see the implementation, really understand what's going on. And clearly you have to implement to really understand from all the questions that are coming here. So object output stream calls replace object to determine what object is actually serialized and sent. And RMI marshaller returns stub if object is remote and has been exported. So RMI basically returns a proxy and says that please serialize that object rather than serialize the original object. That's what replace object says. Replace this object with another object. Okay, so you guys, if you want to ever go and use your own output streams, subclass, and you can replace objects and probably do interesting programs. But this was probably meant for RMI. Okay, an object input stream then gets either a stub or a copy. Okay, and it can tell whether it's a stub or not. Okay, and it goes and sends that object. And did you guys ever study the difference between inheritance and delegation ever in any class? Design and software engineering, David Strauch's class. Anybody took David Strauch's class?
Those are overall
Right. So there is the inheritance means is A, and delegation means
Values.
which is better?
Depends.
How tight you're willing to
Well, it
shuffle.
Okay. So in terms of late binding, which is later binding? Has A is made, link is made at runtime. Is A link is made at compile time. Okay? And I can give 3 lectures on pros and cons between
So
delegation.
by extension, late binding is evil, therefore delegation is evil.
Late binding? No, early binding is evil.
Oh, sorry.
Did I say late binding is evil? I'm sorry, I meant early binding is evil. Early binding is evil. Sorry, late binding is wonderful. So I told you that Doug Comer is a guy at Purdue who influenced me a lot, and there were these 2 rules he had. I forget the third one. Memory is cheap. Early binding is evil, and I forget the last one. Okay, So I'm just saying in red, I mean some drawback. That in the implementation that you guys will see that, I did it through delegation rather than inheritance, so there's much more flexibility. Okay, we talked about RMI registry before. Let's do a review here. So it's got a lookup and it's got a rebind. Okay, and let's just see exactly, now you want the flow, you've got the flow. Okay, so you've got a callee object. They create a regular object, and so what they did was they did an export. When they did an export, they got a proxy object. Then they did a lookup, a rebind. And that rebind, actually, this picture is not quite correct. There's a remote object. They first did an export object where they created a proxy here. I'm sorry. And then they went and did rebind, and a copy of the proxy gets sent to the RMI registry. Okay? And now the caller is going to do a lookup, and they get a proxy here. So the proxy goes from here to here to here as a parameter to this method. Okay? And now when you go and use the proxy here, since there was a port number there, the calls will go directly. They won't go through the RMI server. Okay? Because you know exactly how to get it. You just got the port number from it.
So what time? So this starts with the callee, the remote.
Yeah, callee.
And it starts with them sort of registering it, rebind.
They're exporting it and then rebinding it.
Rebinding gives them a copy of the
The
proxy,
proxy.
and then the caller can do a lookup and get another copy of the proxy caller, which can then communicate with the callee directly.
And the caller rebind
Excellent,
happens,
excellent, yes.
The caller rebind happens as a result of.
So you make a call. There's a call called rebind here. There was an export call already. We saw that. Export call is made at the end, and it goes then, I should really have had, it create a proxy object here. And that proxy object then rebind will send.
So the purpose of rebind is so that the callee and the caller are working on the same object. Okay.
So that's the name server.
Right.
It has a name, and it says bind it with this name, look up with this same name. Okay. So exporting an object creates a proxy and creates a byte communication mechanism. Such a mechanism has not already been created. Okay. So basically, it involves creating, maybe in your case, a selection thread, or whatever, to go and listen to messages now. Okay, so let's look at some code to make this all. So this was the RMI registry server starter we saw earlier. Okay, it goes and creates an instance of the registry. Then it wants to make sure that the process doesn't die. So it does a system.in. We saw this last time. Okay, that's now, I've got my registry in service in place. Okay. Here's what I do at the other end. I go and create a counter. I created up a counter. Okay. I exported the object. What does that do? Creates a stub class, creates a proxy object. Okay. And that proxy object so that's very interesting. How do we know which proxy to send? So rebind then goes and says, what am I doing here? I'm just saying, listen, I can't remember the names. I want to have a simple to understand name. So I'm going to have only one counter in this world. So I'm going to go and say, whatever the name of my counter is, that is the name of that. This is a singleton. So I'm going to use the interface name as the name of the object. Okay? So some string I pass here. I'm using this method to derive the string. And I say rebind counter. Okay? And what do you think export object did besides creating a proxy and creating the proxy class? It had to do one other thing to make this all work.
When I have to open up a port,
A port, okay, yeah, do that also. Fourth thing.
Oh.
So what is going to be passed in this parameter to rebind? You're going to pass the counter value or the proxy. I'm going to send the proxy, right? Which means somewhere it has to go and associate that counter object with the proxy object. Some table, it goes and says, for this counter object, this proxy I have created. Otherwise, export object should go and return back a proxy object. And then you would pass the proxy object. But that's not how they decided to do it. They could have done it that way. They just, that's why things may be a little more confusing. Okay? But what I think is happening underneath, okay, is that they build a table or some way of other way of associating these two things together. Okay? So you're seeing the flow a little bit better now?
Thank you.
So I did not, when I say 0, it just means the default port. Okay? Otherwise I have to choose a port and make sure I chosen a port that has not been used by somebody else. Okay, what if I don't do export object? What do you think is going to happen?
You might blow up.
You might blow up, which would be very nice. But what happens is worse. You don't blow up. And I can't tell you how many hours I've spent because I forgot to put the export object. I don't know why things weren't behaving right. So what could it send? What could rebind send if it's not going to send a proxy? If we did not do export, there's no proxy to send.
Well, I mean, you have your stuff.
Nothing. None of that stuff.
I'm saying that.
There's no stub class. There's no stub object.
There's not.
But it has some semantics. It won't send the proxy for that object, so what else could it do?
Serialized copy, which is only modified locally as a destination. Or the,
Just, I've got this wonderful object. You guys can have it too.
here you go. Yeah.
And if you change it, my object doesn't change. And if you expected that, too bad.
Well, wait, but if it doesn't implement serializable, I thought.
Oh, if it doesn't implement serializable, then you'll get blow up.
Okay.
So we'll happily send just the whole object.
Happily send the whole object.
Okay.
And boy, you forget that export object and you're in so much trouble. Okay? Okay. When does this process, I did not do any, so when you do an increment afterwards, you've done the local increment if you didn't do export object.
What's funny is that so far, about 30% of this discussions have made sense to me. Now that we just get to that scenario at all.
So is that good or bad?
No, that's good.
Is good I confused you and then cleared it up, or I should have?
That's just the crescendo of the lecture.
Sorry?
He got us all confused and panicked, and then it's like, and now
And then you're
it's
just like,
clear, and you guys will see.
So
Or I'm
you,
gonna teach
so
you.
you actually, I was wondering whether I'm doing some, and I had it presented in a different way before, and I thought this was a more pure way of doing it. But I was when I was seeing you guys all confused, I said, oh no, I did something wrong
you
here.
can tell.
Huh?
Okay, good. I'm glad you can tell.
Well, you told me. I don't have to rephrase
I told
it.
you 20% of my confusion.
Just think
I have a good poker face. So.
Sorry?
Just think of it as late binding.
Yeah. Well, that's very
Late
good.
binding
See,
on
I love
your
this. I love this recursive thing. I got to tell you guys. So, I wrote this paper, my first database paper. Okay, and I thought I wrote it very nicely, and it got rejected. My co-author first gave me a paper, and it was just all, not worth sending. So I went and wrote it nicely, and it got rejected. And then my co-author, who couldn't think clearly, I thought, just jumbled it all up. I mean, he sent another version of the paper that took this paragraph, and I had this beautiful flow to explain things so clearly, and he just put this everywhere, and it got accepted. And I finally figured out why. I said, the readers looked at the paper the first time, they didn't understand anything. And they said, this is, but maybe there's an idea. So they read it a second time. And because all the forward references were resolved now, they understood it and they said, oh, this must be great because I got confused the first time, understood the next time. And I went to Doug Comer and I said, Doug, look, isn't this bad that I wrote a nice paper, it got rejected, and I wrote a lousy paper, it got rejected. And he said, you know what? I stopped writing papers and started writing books for exactly that reason. Books are so clear, right? And you think, yes, oh, that's stupid, that's simple. But what is simple is it requires great thought to make things simple. So, no, I clearly need it. I just don't know how to, I gave you all the pieces one at a time in depth so that you could see the whole thing working in the end. If I gave you this code in the beginning, I couldn't quite explain to you what's happening because
Right.
I couldn't explain to you, why export object was in a serialized copy if I didn't talk about serialized copy versus non-serialized copy.
Right. The question is bottom up or top down.
Yeah, and I don't know which is bottom up, which is top down here because
Processes in parallel.
Yeah. We can
yeah.
do that.
So I was just saying, think of one issue at a time, but anyway, but at least this whole thing makes sense at this point. If I'd shown you this stuff before, it would have kind of made sense. So, okay, but still, now tell me, guys, this is still not over. When does this process end?
Which process?
And by the way, you still have you haven't seen nothing as they say it till I come to even more subtleties here. But when does this process end? When does this process die? Because if it died, then there's no counter object to service.
Uh-huh. And why would the client say, "Okay, I'm done with you"? Is that something that happens?
Okay, so
Maybe
all kinds of garbage collection issues arise too.
Maybe like the number of clients referencing it. So how'd you get that?
Yeah,
Okay,
you,
but-
you lost like your linguistic reference to the variable, then you couldn't call like you
No,
could make your
but
name
at this point, there is no reference. Do I want this guy to die at this point? Or there's always a reference in the name server. So, what's going to make it not die? I can go and put a scanner.readline. I didn't do it. Okay, so what must make this process live forever?
Thread.
Yeah, but
With
what?
the registry.
So sometimes the main method, this main method, it's taking some action that's preventing it from dying. Which one of the various actions? Creating this, doing a get registry, would that you think cause it to live forever?
Probably not.
Probably the rebind. It has to be the rebind. Because once you rebind, you're promising that you're going to provide something, right?
If you're doing the rebind, so rebind, except that if you don't export object, the rebind does what?
It just possibly sends them a copy. Right?
So then do I need to live?
With no promise of delivering on it.
No. It sends the whole object. It sends the whole vector other than.
That way, when they get their copy, you being dead isn't really an issue.
Yeah, because their changes never even make it back to you anyway.
So what's going to make it live forever?
Operating.
Export object.
Export object. By elimination.
Ah.
Okay. So serialized copy will be sent if object is serializable. And increment action will not be seen. And when does server terminate? Okay.
That's a good question. When does it terminate?
It-
You can't just terminate whenever there's nothing referencing it at that point because it's not like something can't come later and say, "Oh, I'd like to access your."
You're the server. You've got to live forever. Till your machine goes down. That's the whole point of a server. Okay. So here's the thing. We see that this particular server process is living forever. It's not dead. Okay. And
Wait, the thread is named destroy Java VM.
that's just the thread that exists. No, it's the process that is living forever. It's got many threads in it that Java creates. One of them is destroy VM. Okay. So this does not terminate, and it does not terminate because you have export object, and if you remove the export object, it will terminate. So one of these cases is termination, one of them is not. Terminated. Okay, so this is without the export object, and this is with the export object.
And now it just terminates after it's sent the copy.
Yeah, just says, I'm done.
Well, it'll still increment.
Well, after it increments. it's loaded.
Increments.
Right.
Okay?
Wow. They came together in the end.
You ain't seen nothing yet, I keep saying. And here's what you do with the client end. You get the registry, and it has to be the same registry. And because I am at the same computer, I'm getting the registry on my computer. Okay? Otherwise, registry will take a host and a port number also. Okay?
Is get registry literally cloning the entire mapping? Or is it just
No,
giving
it's
the
getting a reference. You see,
reference? I was going to say, that makes sense. Yeah.
So the whole issue is that you've got a bootstrapping problem.
Right.
You've got a name server. You have to invoke remote methods in the name server to invoke remote methods in the server. So these static methods are your bootstrapping mechanism. Okay? And whenever you do locate registry, if you say get registry, it's saying get me the registry at my local host that is listening to the well-known port that this registry listens to, which is 1099. Okay? If you really want to point to a particular port, a registry, go and give the host name and the port. or just give the host number, and then the default port number will be used. Okay, and you say counter RMI registry.lookup, and you say get value. Okay, and you can go and use that get value method. If you got a serialized copy, the get value method will be called on the serialized copy. Otherwise, it will be called on the remote object.
So we're going to make a registry?
The registry comes.
Right. Oh, no, I don't mean in this case. I mean in one of our projects.
But
build all this.
You'll have to build some kind of mechanism to go. You already built that in the NIO case also, right? You got some way of finding the person. Somebody was keeping track of all the other guys. Okay. So you're doing the lookup. You get the. So I'm saying that there's two ways to get references. Either you can do lookup, or you can just call. Just forget this. What I'm saying. But when you see Gypsy, you'll see different ways of doing it. Okay. But basically, I'm saying there's a bootstrapping method and there's a non-bootstrapping method, and they both are doing remote method invocations. And it's not clear how the bootstrapping method is tied to the non-bootstrapping method. Okay, I want to leave you guys more illuminated or more confused, depending on how much we do in these 2 minutes. Okay, so see what's happening here. I create an instance of inheriting. I create a remote counter, create another counter, export counter 1, export counter 2. Right? I rebind. I have a name for counter 1. I have a name for counter 2. Okay. So in the previous case, I was just registering one counter. I just gave its class name as its name. Now I've got some variables here that I used. Okay. Then I go and say, okay, let me see what I registered. So I went and said, please look up counter 1 and give me back an object, which is my proxy object. I got back the proxy. I sent a proxy. I got back the proxy. Okay. And I go and say, okay, and I do this. I got one proxy back. I guess I didn't get a second proxy back. That's fine. Now I say look up counter. Sorry, I say counter 1 equals counter 2. Should that return true or false? I wrote the equals method. Remember, it works correctly.
Well, that's not identity, right? That's just
Equals,
so it should be
equality.
True.
I wrote the equals method, right? So the equals method in this particular class will be called. And that class, that class takes as an argument as another instance of the same class. And that equals method, let's assume, works right. So it works true. I overrode the equals method, so it works true. Counter 1 equals proxy 1.
Okay, because it's been exported, right? Which means that when you get proxy 1, it should be approximately you expect it to be.
It's going to forward it to counter 2, right?
So it's going to call the equals method on counter 1.
Uh-huh.
Right?
But is counter 1 a proxy now?
No, counter 1 is a regular object.
Right, so
But the proxy is going to forward it right back to counter 1, so it should be true, right?
So proxy 1 is going to forward its calls. And yeah, and I did is proxy, and I said in my implementation, I checked if the other value is an instance of the interface, or did I say an instance of the class?
No, I think you did that in the interface.
So if I did the interface, I said distributed RMI counter. So it is that interface. And then I go and do a get value. And that get value method is going to be called on my, so the local counter is going to be equals to, and so it should return true. Okay. Counter 1 hash code equals proxy 1 dot hash code.
It's going to forward it, right?
Well, hash code is,
That's about identity.
They're like intertwined. When you do equals, you need to do hash code in such a way that.
so that when you do the hash table lookup, if your equals and your hash codes are same, then it's the same object.
Yeah.
Okay? So we don't know what proxy 1's hash code is and what counter 1's hash code is. And it'll be nice if they're the same, but they may or may not be same. We don't know. We haven't implemented hash code. So it'll do whatever the system does. Right? Because we didn't overwrite hash code. So we'll have to just see what the system semantics say. Okay? And I say print line proxy 1.
Is that a two-string? Or
Yeah, that just does a 2-string.
the two-string that you wrote?
So did I write a 2-string?
I don't remember. I don't think so. But it's going to forward that as the point, right? It's going to call counter 1.toString.
Okay. The equals method is being called on counter directly. So there's no forwarding. This one is being called on the...
Sorry. On the actual proxy object. Gotcha. If you're making some call on it, that would make sense. Yeah.
Okay? So you get back this particular proxy and not a counter or whatever. You know? Even if I had overridden 2-string, that's 2-string would not be called here. It'll be that's 2-string of the proxy, and that's kind of the point here, and we'll sort of see what kind of confusion this can cause next time.
Then how would you call the two-string on your proxy class?
How do you put the 2-string in the proxy class?
When you